So now we'll proceed to circuit applications. So here are some steps involved in solving circuits using Laplace transform. So first, change the function into frequency domain using Laplace transform. Second, transform the circuit from time domain to frequency domain. Then, find the response function for the given circuit. Then lastly, change back to time domain with inverse Laplace transform. Circuit applications using Laplace. The Laplace transform supports the initial value from the circuits. The initial value only comes from inductors and capacitors, since they are the components that can store energy. Next is the initial value will modify the circuit into the S-domain equivalent circuit. For inductors, looking at this figure A, so figure A is in time domain. The equivalent circuit in the frequency domain is figures B and C. So how come? So if you remember, to get the Laplace transform of V of t, V of s equals to L times, so the Laplace transform of a derivative. So the Laplace transform of the derivative is equivalent to S times Is minus the initial value of I. So this is what is meant when it said that the initial value is included in the circuit. So this is the initial value. So in terms of voltage, is SL times Is minus L I of 0 minus. So in terms of circuit, Vs is composed of two components. So we have this impedance SL times Is right here. The voltage across this inductor is just SL times Is, which is this term. And then we have a an equivalent voltage source with polarity negative, positive, and magnitude of L times I of 0 minus. So this component is this term right here. Or if we express this in terms of Is, we have Vs over SL plus I of 0 minus over S. So if you look at this node right here, Is is just the sum of the two branch currents. We have a current right here, the inductor, which is equivalent to Vs over Sl, is this term, and we have a current source going downwards with magnitude of I of 0 minus over S, which is this term. So you can use either of the two equivalent circuits. For capacitors, we are given the current as C dV over dt. Or if you express this in Laplace transform, current capacitor equivalent to C times S Vs minus the initial value of V. This is Vs minus S V of C of 0 minus. C times V of 0 minus. For this expression, the equivalent circuit is, that is figure C. So you have Is, and if you apply KCL at this node, Is is just the sum of the currents here and this current source. So the current right here, the capacitor, is just equivalent to Vs over 1 over Sc, which is this term, minus, so since this is minus, so the arrow is going upward to the magnitude of T times V of 0 minus. Or we can express this in terms of the voltage across the capacitor is equivalent to Is over Sc plus V of 0 minus over S. Now for the first term, this component. So we have the voltage across the capacitor. This capacitor equivalent to Is times 1 over Sc. And then we have a voltage source V is equivalent to V of 0 minus over S, and a polarity of plus minus, since this is plus right here. So the same with the inductor, you can use either of these two circuits or equivalent circuits. So impedances in S domain, so for a resistor, it is still the same. For an inductor, it is S times L, and then a capacitor, we have 1 over Sc. So for first example, determine VO of t using Laplace, then assuming zero initial conditions. So first, let's convert our circuit into the S domain. So converting the circuit to the S domain or frequency domain, we have the capacitor with no initial condition. We have 4 over S current source, so 10 U of t. The plus of 10 U of t is 10 over S. Next is we can transform this part using source transformation. We have 40 over S squared, and we have 4 over S, then 4 plus minus VO by VDT in this circuit. By VDT or VO, is equivalent to 4 over 4 plus s plus 4 over s times 40 over s squared. We have 4 over 4s plus squared plus 4 over s times 40 squared. So this becomes over s plus s plus 2 squared. Now, before getting the inverse Laplace of this expression, we need to use partial fractions. We have a over s plus b over s plus 2 plus c over s plus 2 squared. We have 160 equal to a s plus 2 squared plus bs s plus 2 plus ds. Now, if we let s equal to 0, we can solve for the value of a, is 40. So if we let s be equal to negative 2, we can solve for the value of t. T is negative 80. And if s equals to 1, and then plugging in values of a and c, and I'll solve for the value of b. 40 times 3 squared plus b times 3 minus 80. Solving for b, have negative 40. So this becomes 40 over s minus 40 over s plus 2 minus 80 over s plus 2 squared. So converting this to the time domain, we have 40 e of t minus 40 e to the negative 2t e of t minus 80 t e to the negative 2t e of t. Or we can write this as 40 quantity 1 minus e to the negative 2t minus 2t e to the negative 2t e of t volts.